Okay, today we're going to do experiment 9, which is a freezing point depression. So the equation for a freezing point depression is delta T sub F is equal to I Kf C sub M. With your freezing point depression, that means that if you have, let's say for example, water, it will freeze at 0 degrees Celsius. All right, if you put something in the water, like salt, the freezing point is going to be lower, okay? And so that is the amount that it goes down by is your delta T sub F. And so your delta T sub F, your final minus initial, is your delta T sub F. So the final, the way we're going to do it in the lab, we're going to have our pure solvent, we're going to have cyclohexane, we're going to get a temperature freezing. Then we're going to add something to that solution, in this case naphthalene, and we're going to get another freezing point. All right, and so it's going to lower that freezing point. All right, so when you get a delta T sub F, you want this to be a positive number. So as written, it is not going to be a positive number, but we know by definition freezing point depression is going to go down. So we're going to use that as a positive number. If you put the numbers in as written, you will have a negative number. Your temperature of pure solvent is going to be larger than your temperature of your solution. All right, so remember that your delta T sub F is going to be a positive number. It is by definition the amount that it went down from the pure solvent. All right, then your I is ions / molecules in solution. For this lab, we are going to use cyclohexane, which is a non-polar organic solvent. All right, so when you're using an organic solvent, which is non-polar, you always will have the molecule dissolved in that solution, and that has an I value of 1. All right, now your K sub F is the freezing point depression constant. All right, for this, we're doing it in the lab, so we are not going to look it up in a book. We are going to find it by doing the experiment. All right, so we will not be looking up Kf. We are going to be solving for Kf in this experiment. Your C sub M is your concentration in molality. Molality is moles of solute divided by kilograms of solvent. All right. And so again, your delta T sub F is a freezing point depression. We will find this twice. We're going to do it, we're going to do this reaction or this freezing, this experiment twice, 2 different reagents. All right, and now note that in your C sub M, all right, so that is moles of solute, symbolizes N solute, over kilograms of solvent. So that is the formula for your concentration in molality. To find your moles of solute, moles is mass over molar mass. And so the equation that we need is the mass of the solute divided by the molar mass of the solute. Well, that's the moles of the solute, divided by the kilograms of the solvent. So in the first part, we are going to calculate Kf. We're going to do this by using naphthalene. We know the molar mass of naphthalene. It is 128 grams per mole. All right, and so we will also know the mass of naphthalene because we're going to weigh it. And so we have both the mass and we have the molar mass. We're going to know exactly how much cyclohexane that we're using, so we will know the kilograms of our solvent as well. We know the I value is 1 because we are using an organic compound, naphthalene, organic solvent, cyclohexane, and so we know the I value. All right, and so we will then find the freezing point depression because we're going to freeze both the pure cyclohexane and the cyclohexane with naphthalene. So we have everything except Kf, and so we simply solve for Kf, and we now have our Kf value. So in the second freezing that we're going to do, we're going to use the Kf that we found by freezing the naphthalene solution to find the molar mass of an unknown. Now this unknown is soluble in cyclohexane, which means it's a nonpolar organic molecule. And so you will have an I value again of 1, and you're going to know the mass of your unknown. You are not going to know the molar mass because we don't know what the molar mass of this unknown is going to be. We know we're going to know exactly how much cyclohexane that we're going to use, so we know the kilograms, and we are going to get the freezing point, so we will be able to calculate our delta T sub F. And so now the only thing we don't know is the molar mass. So in this second case, we are solving for the molar mass of the unknown. All right, and so like dissolves like. If we are using cyclohexane, which is nonpolar, that will only dissolve organic molecules that are nonpolar. If we use something polar like water, it would not work because water would not dissolve the naphthalene. Water would not dissolve our unknown. Water is a polar molecule, and that would dissolve polar compounds. And so we throw ice on the road. When we have ice on the road, we throw salt to melt the ice. All right, because rain, which is freezing, or whatever, you have sleet, you have whatever, that is water. And so we have to then have a polar molecule, and the one that we use is sodium chloride. And that's NaCl, and that would have an I value of 2. For organic compounds, the I value is always 1. It is a molecule in the solution. All right, so we're going to have a graph. And so we're going to graph the temperature versus time. And so you see this cooling curve. So you have your liquid at the higher temperature, and we're going to lower temperature over time. And then what we should see is a leveling out of a temperature. And what's happening here is the liquid is freezing. All right, and then once it is frozen, it is then going to cool down to the temperature of the ice bath. All right, and so we have cyclohexane, and we picked a compound that is going to freeze above 0 degrees Celsius. If it was going to freeze below 0 degrees Celsius, we could not use ice water as our cooling. We would have to use dry ice, or we'd use liquid nitrogen or something else in order to get the cooling curve. All right, so we are ready to start. There goes a lab bench, lab stool. All right, so here is our setup. We have our ice bath, we have our thermometer, and you're not supposed to stir with the thermometer because they used to be made of mercury. And so we have this copper coil that I got from experiment 8, and I wrapped it around this thermometer, and I'm going to use this going up and down to stir our cyclohexane. And so in here we have our cyclohexane, we have our pipette bulb. We're going to pipette out 10 mils of cyclohexane, and we're going to freeze it. Once we have that, we are going to warm it up, and we are then going to add naphthalene and dissolve naphthalene into our cyclohexane, and then we're going to freeze that. And then once we have that, we're going to have to then get a new sample of our cyclohexane, another 10 mil sample of cyclohexane, and then we're going to dissolve the unknown in there and get the freezing point of that. So we will have to do 3 different freezing points: pure cyclohexane, cyclohexane plus naphthalene, and cyclohexane plus the unknown. All right, so let's get started. All right. So the first thing we have to do is to pipette 10 mils of cyclohexane into our test tube. All right, so we had practiced, well, not sure. All right, so here is, you get it up over the mark. There's one mark for 10 mils, and then you let it go down slowly. And then you let it go down slowly until the meniscus is at the top of the mark. And then you bring it over and you put it into your test tube. And remember, this is to deliver 10 mils, so 10.00 mils. All right, so there's some at the tip that has been taken into account. So we have 10.00 mils of cyclohexane that we're going to freeze. All right, and so the temperature today that we're starting with is 22.0 degrees Celsius. And in the directions, it says to give the temperature every 15 seconds once the temperature gets down to 15 degrees Celsius. All right, so now I have the cyclohexane in the ice water bath, and I have my stopwatch ready to go, and we will monitor our temperature every 15 seconds once it hits 15 degrees Celsius, which is now. So we are going to get our temperature, and we also want to make sure that we watch all right, so 15 seconds. I'm going to go every 15 seconds and give you a temperature. All right, so the temperature is 10 degrees Celsius. So it went down very fast. So within 15 seconds, it went down from 15 down to 10. The next 15 seconds, it's now at 14. Now I'm also going to watch the solution, and I should see some solid forming. And I definitely want to mark down the time that I find some solid. All right, another 15 seconds. We are at 13.5. Another 15 seconds. We're at 13. All right, another 15 seconds. We are at 12. Not seeing any solid being formed yet. Another 15 seconds. We are at 11. All right. Another 15 seconds. We're at 10.5. Another 15 seconds, we're at 10. All right, another 15 seconds, and we are at 5.5. Not sure how that went down so fast. 5.5. And also at this point, I see that, pull it out of the solution, that we have solid. So now we have solid. There is solid in here. And so I'm going to bring it up out of here. All right, and so I am at 4.5, and I have solid. All right, still at 4.5, and I have solid. I'm trying to get the point right when we have solid and no solid at the same time. We are at 5. All right. So now the temperature is going up, and we have no solid. We stick it in here. Still at 5, and we're getting some solid forming. So let's bring it up out of there. We have solid, and we are at 4.5. So we are going to say that the freezing point for this is at 4.5 degrees Celsius. So the freezing point of the cyclohexane is 4.5 degrees Celsius. All right, so now what we're going to do is we're going to add our naphthalene. And we're going to make sure that we dissolve it. Let's see if I added enough of that. That was 0.1159 grams. All right, so that is between the 0.11 and the 0.13. All right, so our mass of naphthalene is 0.1159 grams. Now, before I freeze this, I need to dissolve it. So when you have your solubilities, remember that it's more soluble when something is hot. Of course, it's going to be less soluble when something is cold. And this is very cold cyclohexane. We are still, it's raising, but it hasn't hit 10 degrees yet. It's liquid, but it's not warm enough to dissolve the 0.1159 grams of naphthalene. All right, so I may want to get a warm water bath. And that'll warm it up faster than the air temperature. All right, so I don't see any solid in here now. There's no solid naphthalene. All right, so it is all dissolved in my cyclohexane. So now I'm ready to freeze my solution of the cyclohexane and the naphthalene. All right, so let's see what temperature we can get to freeze this. All right, so if we want to start monitoring the temperatures and times. All right, so if we start now, we started at, it was 11 degrees Celsius. All right, now it's at 9. And now it's at 8. it's at 7. Now it's at 6. Now it's at 5. And now it's at 4. Still at 4, but I don't see any solid forming. Okay, now it's at 3.8, but still no solid forming. Now it's at 3.2 and still no solid forming. It's down to 3. And it is 2.9. Again, no solid. Let's see. Raise this around here, make sure I don't see any solid. I do not see any solid, and we are at right around 2.8. Add some more ice in here. Make sure it has low enough temperature. At it. No solid. Hard to see through all the ice if we're getting any solid formation. It doesn't look like it. Temperature at now? Our temperature is at 2.5. like 2.2 is the temperature. Let's see the solid in here. All right, so now I see the solid. I just couldn't see it before. All right, so we are at 2.5. All right, and now our temperature is 2.8. So, and that's when the last solid was melting. So 2.8 degrees Celsius is our temperature for the naphthalene. All right. Now we're going to take another sample. And do the unknown. All right, so we get another test tube. Thermometer, a second 10 ml sample of cyclohexane, so again, letting that bubble go down slowly, the meniscus goes down until it hits the top of the line. That's exactly 10 mils. That will be then delivered into our test tube. So again, you don't blow out the last amount. It is to deliver. There is some in the tip, but it has delivered 10 mils of cyclohexane into the test tube. So now we want to weigh our unknown. All right, and if you smell the unknown, I'll give you a hint. It smells like a men's restroom. So it is something that would be in a men's restroom, not any other type of restroom. Usually you don't have this smell. Men's restrooms, you have the smell. All right, so we're going to weigh out .11 to .13 grams. So let's see. What one chunk of this weighs. So these are pretty large chunks. Yep, that was too large. Let's find a smaller chunk. All right, so we're going to go with a little more than it asked for. So we're going to use for the unknown mass is 0.1411. So this is not a powder, this is in kind of chunks, so that is what we're going to use. And then I'm going to put that into the test tube. All right, so now I'm going to dissolve it. So there's solid at the bottom, and you got to make sure that the unknown is completely dissolved so that we have a solution. And so again, the cyclohexane is non-polar organic solvent. The unknown is a non-polar organic compound. So like dissolves like, to organics, both non-polar, and it will dissolve. All right. So it is completely dissolved. So there's no solid left in there. It is completely dissolved in the 10 milliliters of the cyclohexane. So now we're ready to freeze this. All right. Okay, so we'll put that into our ice bath. Might have to add some more ice again. Yeah, let's add some more ice. Pour out some of the water. Add a few more ice cubes. All right. Okay, so now we're ready to freeze the unknown. So what we do know is it's going to have a freezing point depression from the pure cyclohexane. So we know that it is going to be less than the 4.5, and that's all that we can say about that. So turning my timer back on. All right, so we are at 9 degrees Celsius right now. So it went down very fast. All right, 15 seconds later, we're down at 8. When the cyclohexane froze, the whole thing turned a cloudy color, and it was easy to see. When our solution with the naphthalene was solid, it was just very fine, solid particles in the solution that I couldn't see with this fog in the way. So once we get down to, say, 2, I'm going to take this out and look at it. We're only down to 7. We're down to 6. All right, down to 5. right, down to 3.5. All right, down to 3. It's down to 2.5. I'm going to pull this out pretty soon and see if I can see any solid in there. All right, still at 2.5. No, no solid. Right, what are we at? Temperature, so right at 2. A little bit above 2. Right, it's slightly above 2, like 2.1. All right, let's see what it looks like. Any solid in there. All right, so we do have some solid in there. All right, let's see. And solid gone. We are at 2.4 degrees Celsius. 2.4 degrees Celsius. All right, so we have our pure cyclohexane. Freezing temperature was 4.5. With the naphthalene, the freezing point was 2.8. With the unknown, the freezing point was 2.4. Your mass of your naphthalene was 0.1159 grams, and your mass of your unknown was 0.1411. With that information, you can now get the molar mass of this unknown. And that is the end of experiment 9.